We like the Bohr model because it's simple. It's easy to view. It's a nice visualization. We can, get the idea of all the discrete energy levels. The thing is there's a lot more uncertainties in the atom than things like the Bohr model would have us believe. So we have a couple of things. We have the Heisenberg uncertainty principle and Schrodinger's equation. So basically what the Heisenberg uncertainty principle is saying is that we can't know everything all at once. All right. So if we think about the position and the momentum of a particle, and in this case, we're thinking about in the case of an atom, in an atom, the particle is an electron. Okay. So we want to know about these electrons. We know that they're not moving in nice little orbits. So where are they? Are they here? Are they here? Are they here? How fast are they moving? Where are they going? And so we want to know these things. We want to know where they are, and we want to know how they travel around. We want to understand what's going on inside the atom, right? Well, Heisenberg says this is impossible. So we get this crazy little equation here. This delta x times m delta u is greater than or equal to h over 4 pi. Okay, we're not going to solve that in this class. We're just going to understand that this lets us know that this is impossible. Okay, the delta h, or the delta x, I mean, and the delta u. The delta x is the uncertainty in the position, and the delta u is the uncertainty in speed. Okay, and so Heisenberg just tells us that we can't know both of these things simultaneously. We can only know one thing or the other. And then there's Schrodinger, okay, where we get this quantum mechanical model of the atom. And solving the Schrodinger equation gives us some more information. And we're going to take a look at the orbitals in a little bit, and we're going to see some probability density maps that come from solving the Schrodinger equation. The Schrodinger equation is incredibly complicated, though. So this is a very simplified look at this. I'm going to put this little caret over the h there. So basically we have this E, which is an eigenvalue, and we have this H with a little caret, cap over the top of it, which is a Hamiltonian. And then we've got these wave functions and these probability functions, and it's super complicated. It requires a lot of calculus, and physicists do this, physical chemists do this. Yeah. So anyway, Schrodinger tells us that, we've got this quantum mechanical model, and Schrodinger helps us predict where the most likely positions in an atom that we would find electrons are. Okay, and so it's super complicated. There's a lot of variables. We've got the behavior of the electron. We get this mathematical wave function, and we have all of our orbitals. We've got our s, p, d, and f orbitals, and each orbital has its own set of variables called quantum numbers. We can do a little bit with quantum numbers without having to solve the Schrodinger equation, which we will do in this unit. But we're not actually going to solve the Schrodinger equation. It's very complicated. You need a lot more math and a lot more chemistry and some more physics before you can even begin to solve the Schrodinger equation. But a lot of people have worked on the Schrodinger equation, and so we have the ability to look at some information that we have been able to glean from the Schrodinger equation. So the whole point of this little section is that there are things that are uncertain. We don't know everything. And even now, I'm recording this video in March of 2025, and we still don't know everything. There's still lots more things to find out. But we do know a lot, and we can take what we know to, continue to build this picture of what's going on inside the atom.